Welcome to BG Academy. Today I will tell you why common rail injection system is better than the classic one, the mechanical one. So firstly, a few words about a mechanical injection system, the one that bases on mechanical injection pump. There is actually two solutions you can meet. One is the injection pump with many pumping sections, as many cylinders is on the engine. And the other solution is a one pumping section and a distributor that directs the pressure to the injectors on the cylinders. But our main focus would be the pumping section itself. So the mechanical pumping section is activated by the cam on the shaft. So the cam acts on the plunger, and the plunger moves up in its cylinder, and it generates the fuel pressure above, and that pressure going through the pipe to the injector, when it reaches a certain level, it opens the needle on the injector. So the injection process starts. When the pressure generated by the pumping section drops down, the injector closes, the needle closes injector, and the injection process ends. This is how it works. So what is wrong about it that made designers to look for another solution? The simplicity of this mechanical system has its cost. Basically, the mechanical pumping section that generates the pressure is responsible for opening and closing the injector needle, and also is responsible for generating the fuel pressure. So it has two functions, as a matter of fact. And in fact, we can influence the moment the injector opens and closes only indirectly by generating pressure inside the pumping section. And the pressure that is being generated in the pumping section changes with time, changes with the injection process, as the injection process goes. So in reality, the pressure at which the injector opens, the needle opens on the injector, is much higher than the pressure at which the injector needle closes the injector. And all this happens under constantly changing injection pressure. So we poorly control the injection pressure, and also we poorly and indirectly control the moment injector opens and the moment injector closes. As a consequence, the spraying quality is also very poor in such solution. So this was the reason the designers were looking for another solution to get it fixed. But how to fix it? How to bring a new quality to the injection process itself? The idea came from gasoline injection system, a multi-point injection system to be exact. Because on the gas engine, the multi-point injection system is built exactly as the common rail. It also has a common rail that serves as pressure accumulator. It also has an injectors driven or managed by the electronic. So the idea was to adapt the gasoline injection system to the diesel injection system. Why it's supposed to be better? The main factor that brings entirely new quality is separating those two functions, generating pressure and managing opening and closing the injector. And this has been separated on the common rail injection system. There is a separate pump that generates the pressure, the constant pressure in the common rail. And there is an electronic system that manages opening and closing the injectors. And of course, a challenge for adapting the gasoline injection system to the diesel injection system was the pressure itself, because the pressure on the common rail system is more or less, roughly counting, 500 times bigger than on a gas injection system. A gas injection system works under approximately 2.5–3.5 bars, but common rail works under pressure of 14 or 18 hundredths bar. And common rail brought an entirely new quality to the injection process on the diesel engine, because now electronic system can precisely open and close the injector exactly when it's needed, and the spraying quality remains almost the same during the injection process. Moreover, we can initiate a pilot dose being injected prior to the main dose. We can literally do anything with the injector, having the electronic being managing the injection process. So this is exactly why the common rail system is so much better and brings so much more quality in controlling injection process, and in consequence in economy and ecology of the diesel engine. Without a common rail system, it would be literally impossible to equip all these after-treatment systems on the diesel engines, because the entire after-treatment system requires very precise and very accurate injection process.